In the last lecture, we were learning something about the laws of motion. However, I think it was a very small broken video. So let us recapitulate what we had seen in the last chapter. In the very first chapter, we have learned about motion. But we have not learned why motion occurs. It is a very common experience that if a book is lying on the table, it will keep on lying on the table unless someone moves it from there. Okay, it is a flat surface, so we may say that it may keep on lying on the table. However, even if we take a ball and put it on the floor, it will stay on the floor unless either we push it or pull it. So this push or pull that we apply onto the object to bring it in motion is called force. Galileo was the first scientist to observe that objects do not start moving on their own. And to confirm this, he prepared and performed a beautiful experiment. He took an inclined plane, inclined at a particular angle, let us call it theta, applied a lot of oil onto it to reduce the amount of friction that would be there. He also took another inclined plane which was inclined at the same angle. He measured a particular height placed a ball there and allowed it to move on its own. The ball rolled, climbed on to the other incline, reached a particular height, stopped and rolled back. When this height was measured, we found that it was the same as the height from which the ball was released. This was, so to say, a shocking result. So what we did was that instead of keeping this inclined at the same angle as the first one, he reduced the angle and made it less than theta. Again the ball was allowed to roll. It reached a particular height and rolled back. Again, when the height was measured, it turned out to be the same height as the ball was made to roll from. Again, it was a shocking result, and therefore, now he reduced the angle greatly. Much less than theta, and again when the experiment was performed, the ball reached a particular height, and when the height was measured, it again turned out to be the same as the initial height. From this, he came to a conclusion that traveling of the distance was not important. Attaining the same height was. Because when the inclined plane had the same angle as theta, it traveled only so much. And when it was less than theta, it traveled a lot more, but achieved the same height every time. From this, he came to a conclusion that if instead of an inclined plane, we will have a plane at 0 degrees, the ball will keep on rolling because it will never achieve the height h. And unless it achieves the height h, it is not going to stop. From this, he gave us a law which is known as the law of inertia. The law of inertia said that a body at rest will remain at rest, and a body in motion will continue the motion with uniform velocity. That law of inertia was given to us by Galileo. Newton made further study on this particular law. That yes, body is supposed to be moving or keep on moving with uniform velocity, but in actual practice we find that it is not true. Whenever we roll a ball on the floor, it goes up to a certain distance and stops. Because it is now known to us that this happens because of a force that opposes motion, and that is friction. Friction acts exactly in the opposite direction of the motion. Newton said that a force is applied onto a moving body, either it can be made to stop. If we give it a little tap as it is rolling, it will roll faster and cover a greater distance. And if we just tap it from a side, it will change the direction. And remember, we have already learned in the last lesson that a change of direction is a change of velocity, though speed need not change. So to bring about a change in velocity, the body at rest to be made to move, a moving body made to change direction, go faster or stop. For all this, we have to apply some kind of force onto it. And therefore Newton's first law of motion is a mere extension of the law of inertia as proposed by Galileo. The Newton's first law of motion tells us that a body at rest will remain at rest, and a body in motion will continue to move with uniform velocity unless an unbalanced external force is applied on it. The moment we apply an external from outside, unbalanced, balanced forces will have a resultant as 0. So one force has to be greater than the other one. So unbalanced, external, unbalanced force. If we apply, the moving body may stop, a body at rest will start moving. To a moving body, we can make it move faster, we can make it change direction. Changing of direction again is a change in velocity. And therefore the velocity will not remain uniform. So the first law of motion tells us the effect of force on an object. A body at rest will remain at rest. A body in motion will continue to move with uniform velocity unless an external unbalanced force acts on it. The result of the application of force is change in velocity of an object. How much is the force to be applied? This answer is given to us by Newton's second law of motion. This law tells us about the